Hello friends, this is Kevin, but only if you truly believe, and today I'm doing question 1 from the homework number 8. So I'm going to assume most of the problems with C, but I'll go through one at A and B too, as well. They're exactly the same, but just different numbers. So for A, we're being asked about the speed of the car of car A and B. So this is really just one problem. So some things you need to remember: work equals force times distance, and the change of work also equals kinetic energy, work energy theorem. So first you need to find the work of car A, which is just force times distance. The distance should be given to you. In my case, it's 9.8 meters. The force is just frictional force, which is just gravity multiplied by the coefficient of friction, multiplied the mass. So you should multiply those together to get your force. You should have all these numbers. Don't use 10 for gravity, use 9.8. So then for force times distance, you use your force that you got, your distances you're given, multiply them, you get the work of the car. And then you set this work equal to KE, because remember, work energy theorem. So then KE equals 1/2 mv squared, so you can set your answer from work to 1/2 mv squared. Multiply both sides by 2, divide both sides by the mass of the car, and then square root it. And it's the exact same process for the B. Just imagine all these said B, not A. I actually forgot to change that. I'll change that afterwards, but all this should say B. I literally just copy and paste it and change the numbers because the process is exactly the same. So either way, moving on. And then for C, this question is asking, assuming that momentum is conserved, find the speed of the car just before acceleration, just before a collision. So you see, at first, only B is moving, and after B and A is moving. And we're told that linear momentum is conserved. Also, you should just assume this, because if they didn't tell you, this problem would be impossible to solve. But yeah. So we know that momentum is conserved. If you remember, momentum is just mass times speed. That's about it. So this means the mass times speed of car B right here needs to equal the mass times speed of car B here and here. But we don't know what the speed of car B here is. That's the only thing we do not know. However, we do know the speed of the car B here. That's the answer to our part B. And we do know the speed of car A. That was the answer to part A. And we do know their masses. So we can set up an equation so that the mass of the car A times the velocity of car A plus the mass of car B times the velocity of car B, which is this point, and that's their momentum, should equal to 1,500, or whatever your weight of car B is, times what the speed of car B. So then you set up your MA, VA, plus MB, VB. These should be given, and then the speeds you should have found equals your weight, mass, times V. And then you just divide each side by your mass of B, and then you should get your velocity. That's how you do this problem.